Hi, I just want to talk about videos like this on YouTube where someone zooms in over a patch of water and they actually zoom in on the horizon, which is really cool. But you can see objects past the horizon, whether it be buildings or ships or something, and the lower portions are blocked from view. Well, the average person looks at that and says, wow, that's curvature of the Earth. And, that's understandable. That's what we've all been taught. What I want to show is that it can't be curvature because there's no curvature on the horizontal axis. And what I want to show is that this is perfectly consistent with perspective. This is exactly what we would see. So here we go. Okay, a little something of how perspective works. See the red and the yellow line. The yellow line is your eye height. The red is the ground plane. And the ground angles up. It visually angles up to your eye level. It's on a trajectory. So the way perspective works on a flat plane is that where that intersects, the ground plane and your eye plane intersect, is where the horizon will form.
So you won't see any more ground past this point. Once it intersects with your eye, right, it intersects with the center of your eye, that's it. You can't see any more ground past that point. You could see objects beyond it, but they're going to start to get blocked by that point where the ground stopped. And they're going to get blocked from the bottom up. Okay, and for those who don't believe that the horizon goes to your eye level, that all the parallel lines and planes angle to your eye level, just take a look at that wall down the left-hand side there, right? The bottom angles up and the top angles down, and where it converges is right in the center of your eye. That's where your horizon forms. The ground angles up to your eye level, and then you can't see any more ground past that point.
You know what I mean? The ground comes up like a big wall. It's a big ramp. And when it gets to your eye level, you can't see any further. You cannot see any more ground, or in this case, any more water. You can see beyond it, but the bottom portions of things are blocked from view. So that's the reality of our vision. Wow, look how that water ramps up to your eye level, and it forms a wall. Incredible zooming in on that horizon. Notice the buildings behind it, the lower portion is blocked. That's due to perspective. To explain this illustration briefly, when they say they see curvature when they're looking at the buildings, and they're saying because the lower parts disappear, they're calling that curvature. That would be on the z-axis. That's from our eyes to the horizon and beyond. On the x-axis, these are the two that we're concerned with, the z and the x. The x-axis is the horizon, or our horizontal axis. And the x-axis is the one that we don't see any curvature on. They claim to see it on the z, but they say, oh, you can't see it on the x. Well, you should and you must see it on the x, and yet we do not. Okay, here we are looking over the bay. I have it mocked up here so you can... I have the X, Y, and Z axis, and I got a line across the horizon. And you'll notice I have a guy over there on the right-hand side of the screen, and he's looking across to the left. So the point of this is that here we are looking across this patch of water, and the guy on the beach here says he sees curvature because the building's way off in the horizon. Once you zoom in, the lower parts disappear, so he's claiming curvature on the Z-axis. Yet, we take this guy over here to the right, and let's say he's doing the same exact thing. He's looking across the same patch of water, and he sees buildings off in the distance, and the lower portions disappear, and he's claiming curvature. Now, his z-axis is our x-axis.
So we should see his curvature.
See what I'm saying? So what I'm going to do here in a second is I'm going to zoom in on this whole, the zoomed out shot of the horizon, and we're going to scan it from right to left, and we're going to show that there's no curvature on the x-axis. Okay, here we go. Look for any separation between the horizon and the straight yellow line, especially at the beginning of the picture and at the end, or the right side of the picture. That's where they say you'll see curvature. So we look, and we have, I put a little gap between the line and the horizon, and there we go. Looks perfect. Okay, and we're going to maintain that gap all the way across. You know, I can't believe they try to get away with this. You know, they say you can't see curvature, but then they see the buildings' lower portions disappearing and they yell curvature. But here we are. Here's the horizon. Nice long patch of horizon, and let's look at the end. Perfect. Not an ounce of curvature.